Hello, everybody, and welcome to this part 57 of the Arduboy dev stream. So I have changed some stuff outside of the video, the stream. So I will show you the change first, and then I will explain what we will do today. So today we still need to implement our progress function. How to save that. So yeah, last stream we refactor a little bit the init function in order to memorize the alive status of the living items that can die, and if you go back to the previous screen, they should not respawn, but if you die yourself, they should. So yeah, that's a complex mechanism, but we want to try to do it as small as possible, of course, to minimize the footprint on the program. And basically, we want to reuse. The goal is to reuse the number of instance of each type of item, also to minimize the program that we will use. So first, I will show you what I've changed. With no surprise, and this is what I told you during the last video, I refactor. So the same. I made the same change that what we made on the enemies, and I did it for all the item that we have in the game. So we can go through that, and maybe through that process, I also find some maybe optimization that could be done, or some little refactoring. So all right. So the first thing I've done is to move the init function that we just wrote for the enemy, just for testing if it was okay. I move it to the item class so that it can be used by any living item. The function can be reused. So yeah. So before there was the init function of the enemies that we use the enemies to prototype this new init pattern, and I move all of that to the item class. So we have our new init with the respawn flag, and and the init function now also have it, and we'll use the progress also to ask if the item is alive. And in the same time, I found there was a little bug here, because we were testing if the function is scorpion, but this function is testing our own property flag, and the property was not set inside the init function, not set yet. It will be set in the init of the item. So actually you have to test on the flag parameter itself to make it correct. And you will see later I've changed this again. So all right, so that was just moving that to the item. Then we can start to change the pickup item. So the pickup item, so we remove the constructor with the alive. So all the alive flag will be set now through the init function. And that means in the startwet we also remove the constructor. We don't need it. And also the respawn, as we have seen with the enemy, this should be removed. Also, we don't set the live flag again in the respawn. We set it into the init, depending on the should respawn parameters of the init. I think that's the same for the bullet crat. Remove the constructor. Same, and remove the respawn. And same for the dynamite crat. Remove the constructor. Remove constructor and the respawn. For the item, so I also add the progress set alive this here inside this init function. because the property flag here is directly set. We don't call the set property in that init function. And actually I want to keep it like that because I really want to clear the whole property, to really reset the whole property flag with what is specified here. But if we do that, that means the set item alive is not called, because if you remember, this function is called inside the set property of the item. So I also had to add it here to fix a bug. And map data, I just try it with the statuette. So yeah, it works. I won't show you. You can you can trust me on that one. I've tested it. All right. So this was the refactoring for the pickup item. I done the same refactoring for the destroyable item. So that's the same. I removed the constructor here. I just moved the static init a bit higher. So I just removed the constructor. However, you may notice that there was another flag set in the constructor. The destroyable item must have the destroyable block set. I mean, the destroyable block, you need to have this property set, and it was set in the constructor. But now, if you remember, we override the init. We override the property flag in the init function. So that means this destroyable block flag was also deleted and reset. And this was a bug that also existed before if I wanted to reuse the instance. And now the goal is to reuse the instance. So this is why I move the set property destroyable block inside the respawn function. So now every time the block is respawned, I also reset this destroyable block. And of course I remove the set of the alive, which is handled by the init function. Just move the break here, nothing special. So that's the destroyable, and then I decided to do the same to use the same pattern for the enemy. So I remove the specific init function from the enemy. That was, remember, using the if I'm a scorpion, then I'm not a trap triggerer. And now I just, so I remove this whole function that was calling the item function. And then I just, in the respawn, also use the same logic, like moving the, if I'm a scorpion, then I set the trap triggerer. And now I just put it into the respawn. That makes the pattern more identical to all the items, so I don't need to have this specific init function for the enemy. And now I can also use the isScorpion method, because the property has been correctly set when the update respawn is called. Alright, so that was for the enemies. About the item, so we have, a common init, so a little bit more refactoring here. So now I have a common init, and the previous init function is now here. And what I've done here, why I've done that is because I just realized that actually we could use the add item. Well, it was both for partially for fixing a bug that I noticed, and with the destroyable block actually, and also to optimize the code of the map data. So let me show you something else before. If I show you the map data, I just realized that the add item that we have in the init screen, this could be done inside the init function of the item itself. Why calling both add item here and then also calling init function on the same item? So yeah, if we just move it inside, then this is less code, so it's more optimized. the init function will be smaller. We use less code, obviously. So yeah, I think that was better, and also that was fixing a bug, because for the destroyable block, it was added, and maybe also had to be removed manually. So that's what I've done here to fix that bug. So basically, the init with the respawn flag now is doing the hide item, but if the flag is false, I should also remove from the map manager, and that could happen like I have a destroyable block. For example, in first screen, second screen, I destroy the one in the first screen, go to the second screen. So second screen, the block is reused and is respawned, and it is added to the manager. Then I go back to the first screen, and the destroyable block is dead, so it should not be updated. But it was still into the map manager item array, because in the second screen I didn't destroy it yet, so it's still there. So it was not killed, so it was not removed. So yeah, I think that's fix a bug that makes the flow easier to understand. And because of that, then of course, if I want to remove the add item from the map data init function, screen function, then I should also handle the case for the item that are not alive, that are always alive. And this is why I end up doing this init function, add it to the manager, and then call the common init. So the common init is called here, and it's called here. And obviously, if I'm not alive here, I should not call the common init. I don't need to call the common init, actually. But I still need to call the progress, and I still need to remove the item and call the progress. All right, so what else I've done here, and the stalagmite also same, remove the constructor, and yeah, just remove the constructor and the respawn as usual. Yeah, so that was this. Then after I fix a bug, well, I tried to fix a bug, but I've done a bad fix with the arrow bullet and dynamite. So I revert this change, so I will not change it. I will not show it to you. Well, I can show you. I thought it should have been good to just do the remove item here in the kill, but no, it's not good, because, and I forgot, and I already explained that before, but I forgot the code. It was a long time ago. Because the map manager is iterating on the item array, so it's better to return the boolean value if you want to be removed. Okay, so then refactor the arrow launcher. So I guess it's very similar. We just remove the constructor. However, the arrow launcher need detection width as initialization value. So that means I also need a new specific init function which take the detection width, and yeah, so the constructor just create its own bullet, but then the init function set the detection width and call the init of the item. The arrow launcher cannot die, so all right, and that was also some kind of test. Then I refactor the stalactite. Again, I remove the property flag alive, and I test it, and then I revert my bad fix. So So what was the bad fix was, yeah, if you kill immediately the bullet, so the kill function, the kill bullet without sparks can be called by Rick, for example, or by the arrow launcher if um, we need to if the player die, for example, and we need to respawn the player, so we should call stop all the gameplay, and that is calling this kill bullet without spark. So basically, before I was doing this, which is bad. So now I just set the frame ID to a specific value, and this specific value will make it return true in the next update. So the proper fix was actually this line, only this line, and that's the same for the dynamite. The proper fix for the kill, well, actually it was already set to -1, but the proper fix was doing this. If it's -1, I just return true. Otherwise, I can just do what I have to do. All right, so that's it for the change outside of the video. And now I prepare something for what we'll do now, which is try to implement the progress. So I've made a small document here to try to estimate the number of instances of each item that we will have. So right now, because we will reuse the item, that's the goal, reusing the item for every screen, you can think about how many items we will have in one screen. This is the list of all the items we have developed so far and that we could place in our level. So the first one are the pickup item dynamite, statuette, dynamite, crat. Oh, I guess there will not be more than one in each screen. So one statuette. It doesn't really make sense to put two statuettes in one screen. Doesn't make sense to make two dynamite crate in one screen. That's too much, right? Actually we will have one dynamite crate every 5 or 6 screen, right, to put some pressure on the player. So I guess that's 111. Destroyable block, probably 1, maybe 2 if you want to have a complex puzzle. Yeah, stalagmite, 1, maybe 2. I was a bit generous here. The spike, I think there will be more because they are very tiny spikes, and you want to place quite a lot of them to make a. So for example, you can have vertical spike when you jump, and if you put several one along a wall, so the player have to avoid it. So yeah, something like 5 maybe. Yeah. Arrow launcher, yeah, you may have one here, another one here, maybe 1, 2, 3. That's reasonable, I think. Enemy 3 maximum, I guess, but because you can have the scorpion, so you can have a scorpion running over there. 1, 2, mummy. Why not? No more than 3, I think. And the stalactite, yeah, maybe you can have 3 in a row like this, so why not? Around 3. So overall, the total, I think we will have a kind of 21 instance of item. And now there was different way of implementing the progress. So I thought about 2 different ways. So the if you remember, we need to record per item and per ID, per screen ID, basically. So for each screen ID, which item die. So you can see it in 2 different ways. You can see it for each screen ID which item die, or you can see it for each item in which screen I'm dead, right? But basically it's like a double a dimension array, kind of. You can see it like that. and writing code for remembering for each screen. Yeah, for each screen which item die. Maybe a bit complex, and maybe use a lot of space of program, right? Writing the other way around for each item which screen I'm in is a bit easier to implement, I think, because for each item, so basically we get the address of the item, which is int, the size of an int, like two byte. And then so you have 2 bytes, and then for this 2 byte you can associate, you can, for example, associate one char, and in that char you can use 1 bit for each screen. So screen ID 0, the first bit of this byte of this char, if you want. Screen ID 1, second bit, etc. So in one char you can save 8 screen. So you can have your 2 byte for the address of the item plus 1 byte for one screen, for 8 screens, sorry. And if you have more than 8 screen, you add another char, so you have 16 screen, etc., etc. So basically that's why I was counting how many puzzle screen I think we may have in the game. Let's say I put 24, and then that means the size of the progress will be the number of instance multiplied by the number of screen divided by 8, because on 1 byte for you can save 8 screen in 1 byte. And actually I should add the 2 byte also, which I forgot, plus the 2 byte of the pointer itself. So this is the 2 byte of the pointer plus how many char I need depending on how many screen I will have, right? So that means the size of the progress will be around 100 bytes, which is not nothing. I start to, yeah, like I say, usually one puzzle screen, I mean the static sprite ID is like around 50, 60, so it's almost like 2 screen. So we use the size of 2 screen just to save the progress of the item. Was not super great, not super happy about that. But anyway, I thought it was I have the second way of doing it. I'll talk in a minute, but yeah, I thought it was quite easy to store the information like that. And then I was thinking, oh, okay, but if I have something that is associated to each item, maybe I can just store this flag inside the item class. So maybe not all item class, because the yeah, actually this number is not exactly correct, because I store all the, I counted all the item, but there is some item that doesn't die. So let me this one maybe, let me move it here. Sorry. So the spike and arrow launcher, they don't die. And statuette, yes, die. Bullet crate, yeah. Destroy block, yeah. Stalagmite also can be destroyed. Enemy stalactite. So actually, this one can go. The total can go up to B9. Yeah. So okay, that reduced to 65. But yeah, so I was thinking we could have, for example, an intermediate class after the item in the class hierarchy. We can have the living item, and inside this living item, we could have this flag, this array of char to save in which screen I am alive or dead. This specific instance is alive or dead in which screen, right? And if we do that, then actually we don't need to save this extra 2, because it's just attached with the instance. So okay, now it becomes a bit more reasonable, like this. So that's the total living instance. Yeah, so for example, if I have a 20 screen, puzzle screen, that means I will have an array of 3 char in the living item instance, and all these item will inherit it from this living item. And yeah, they could save it. They could, and even in the init or whatever, they could save the set a bit into this array of char to remember that okay, I'm alive in screen 0, in screen 3, I'm dead in screen 4, I'm dead in etc. So yeah, that will take that amount of space. The other idea would be to, again, like I said, use the flash memory to save this information. But I want to be friendly also with the flash memory, and the flash access may be a bit slow also. Slower than the RAM for sure. So what we could do is to have save the status of alive or dead of the living item in for the current screen, puzzle screen. So in RAM, so we just save it, yeah, in certain way locally, and then when we switch the screen, we can just save the current screen status to the flash, and then load from the flash the new status of the next screen. So we can have a function that do this update, save and update, and giving the previous or giving the current screen ID and the next one. If we do that, then my estimation of the size will be this one. So basically, the question now is how many living instance you may have in one screen, because we will only record this in RAM. And let's say I think around 6 living item will be in one screen. And if we have 6, then the size of the array to memorize this item pointer, because there are pointers like 2 bytes per pointer, so it's basically double. It's like 12. Yeah, so basically I can just have in the progress class, I can just have an array of item pointer to record the living one or the dead one, and then when I switch screen, I just dump this information into the flash memory. And that makes seems a bit more smaller, a little bit smaller, like 12 byte instead of 39. um, and it probably grows more slowly. It grows slower than if I have the first solution, because yeah, I don't know, if I just add one more stalagmite, for example, here in one screen, then boom, we increase that number. But here, if I decide, oh no, I just have one more living here, I don't grow that much faster. So, and that depends also on the number of puzzle screen. If we can have 20 is my kind of target minimum. I would be disappointed if I cannot have 20, but obviously I want as much as possible. Remember the wall level grid, we can put yeah, I forgot how many, but hundreds of screens, so we are not limited by that. Yeah, so if you have like 32 puzzle screen, then this increase quite faster. But if I have 32 here, it doesn't change. I mean, I can increase here with that solution, I can increase the number of puzzle screen, but the size of the progress will stay the same, because basically I save the information in the flash memory and I just take the one for the current screen. All right, so I guess you understood. I think I will go for that solution, even if that may be a bit more complicated to implement, maybe, than just having an intermediate living item class. That would have been easy to implement, I think. The second solution also may generate more code, probably, than just having the intermediate living item class. But yeah, like I said, maybe this one will be more constrained. I mean, the footprint for the memory footprint for that will be more stable, even if I increase the puzzle screen, which is my goal. All right, so enough talking. Let's try to implement that. So we are in our progress here. Basically, what I want to do first is to have an array of item. I will probably copy some code, and copying code is not the good things to do with the Arduboys, because you want to save as much code as possible. But we could have some refactoring to share the code. Maybe it will be useful. So basically, I just want to copy the add item and remove item function, and having your an array of item. So just copy this. For now, we'll put it here. And I need also, I'll copy the declaration on probably some in the CPP. The item to update here. So and here you can see that there is also a variable that we put here. And I put 20. I was very generous. Maybe not. I'm not sure. This variable actually can be computed by the level editor. So I will also probably move this into the level editor. But okay, let's move that, something similar to the progress. So I will remove the alive, and I will call this. So we have a choice. We can either remember the alive item or the dead item. I think I'm going to remember the dead item, because normally when you start a screen, all the items are live, so maybe it's easier. It will generate less code if we just do it like that. And here I will move that, not exactly the same variable, but similar one to the map data, because like I said, we will generate it. Yeah, actually we could have been a define or a static const expression, int expression, but I don't want to manage two files, so that's a bit crazy. So I will just use a char for that. Constant sign char, and I will call it max max item count per puzzle screen. So declare the max number of item on each puzzle screen. Actually, 20 is not that great, not that crazy, because we have transition and some item has to live while they are transitioning. That's by the way another question for the map editor. Currently in the map editor we compute the max number of item per type, and we instantiate this item here. Actually, so that means when we transitioning, let's say I just have one statuette or one bullet crate. If I have one bullet crate here and also the same bullet crate in the next screen, that means when we transition, the bullet crate will disappear and reappear in the next screen. And if you don't want to have that, you need at least to have two bullet crate. So basically, the editor can count the maximum number of items in between two screens that is transitioning, and just instantiate this number of item, and it can do the same, count the maximum item on two consecutive screen. But just to simplify, we can just call it like that. Max item. We can do that later in the editor. Max item count per puzzle screen. Okay, and for now we'll leave it 20, and I also call max living item count per puzzle screen. And for now we'll just put 4 just for testing. Okay, and then we can just declare these two variables as extern in the map data. Next to the other one, I guess. Where did I put the other one? I don't know. Let's sprite for the wall. I guess I'm using it. Let me search it. Where's my... I'm in the sprite data. That's why I cannot find it. I want to go in the map data. Yep. Okay, yeah, that makes more sense. Yeah, here. So that's an extern. Yep. Let's remove this, okay. The max number of items. Okay, so that means I can, this one, I can replace it in the map manager here, like map data. I can just delete this, and probably I'm using it somewhere else, so let's replace it actually. Okay, here, no, here I don't need it anymore. Okay, I just use one place. So in that way it would be more optimized, because the map editor can level editor can compute exactly the exact number. The map editor should also be careful about the bullet and dynamite and stuff like that. They are added to the map manager. So yeah, it should have had some buffer. But anyway, that's safer that way. And I can also do the same for the put the map data here for the progress here. So but this time I want this one, the living item. Okay, so that's our array for the dead item, and the variable we need, dead item count. All right, so now we can change our add item. So do it in the progress. I guess I don't need to progress with the number. We'll see that. So we need to declare the add item. Okay, so need to change this variable. Search is the item is already inside. Yes, I need to rename the let's use the replace function, because we may have a lot. Okay, and this by this one. Okay, so so we are iterating until we find it. If we have if it's already in, we just don't do anything, otherwise we just add it. All right, so that's our add item or remove item, iterating. If we found it, we remove I. Okay, I can probably just merge this one, because I'm sure we won't have a remove item with count. So we decrease one, and we replace the index by the last one. Okay. Yeah, so I was talking about this duplication of code. So if we want to reuse it, but I will try that outside the stream, is probably to create a small class that is a kind of list of item, something like that, a list of item class, and both the manager and the progress could use that. And yeah, however, these two size will be different, but maybe it will still generate less progmem because the code is not duplicated. So this is something we can test. All right, so I will just precise a little bit, add item to dead pool and remove item from dead pool. Otherwise the code will be a bit strange. And let's declare the remove. Okay, and now we can try to modify our function. So, okay, set item alive. So yeah, I don't need anymore the puzzle screen ID, because like I said, we will always record on the current screen. So basically, if it's alive, I remove it from the dead pool. Otherwise, I add it to the dead pool. So yeah, actually, the simple fact of being in that pool or in that list means that you are dead. If you are not in, you are alive. Okay. I gave the is alive is something like this. Is item alive? We should iterate on this, and if we find it, we return true, and we return false. That means we are dead. Otherwise, if we didn't find it, we can return true. All right, so that will just work for the current screen. Reset progress. So we should, like I said, we should clear all the dead. So that's why I'm saying we just do that. The item count is 0. We don't need to to clear actually the real array. We don't care. Okay. And so the next function we need to implement to make it work is this transition function that I was talking about. Okay, and yeah, that has to be a public one. So void, I can call it save progress, and or maybe I will just save and load progress. And we will have sign char current screen ID to save, and sign char next new on new screen ID to load. Okay, so we have to write this function also. So now that this function is called, that means I don't even need to access the current screen ID in the map manager, so I can remove that. Get current puzzle screen ID. Okay, let's remove it. And okay, so this is where we want to save it in the EEPROM. The function should be something like that. EEPROM update. So update is better than set, because update is checking if the value change. And we can have the EEPROM get, I guess. So this is code from I don't need to integrate. I don't need to. Yeah. Which header I need to integrate? Include EEPROM.h. I guess we need that. We'll see if that compile or not. All right, so so yeah, which address and what to write. Okay, so basically depending on this one and this one, we need to know in which char we need to write. So obviously byte to save byte count, no, not count, save byte number. So basically it's this one divided by 8, right? So and new load byte number, this one. Okay, so then we will iterate on our current dead item pool. So everything in this array we can write it down. And so the address, I will think about it later. Actually, we need to think about it now. So so basically the way I want to save it is I want to save first 2 bytes for the address of the item, and then so this, which I cast into int. So I want to save this this address, and then after that I want to save a certain number of char, and like I explained, each bit of this char said if you are alive or dead. So I need another loop. So J, and J will iterate on the number of char we need to for saving all the screen. So, and that also depends on the map manager, how many screen we export. So we may need later the exact number of screens. So let's just call it puzzle screen count. So let's do that in the map data. We already have it. Yeah. We already have it. That's a good news. Okay, so puzzle screen count, we have it. So I just need to this, and we divide it by 3. But let's put another. Let's put that in the char. And time char byte count divided by 8 also. So that's not totally exact. So for example, if I have 20 screen, then I will only have 2, but at least, but actually I need 3. So depending on the modulo, I need to add more. So if not 8, 3. If this modulo 8 is not 0, then let's just add 1 more. Okay, that's the compute how many bytes we need to store or 1 bit to store 1 bit for all the screen. Okay, so here I need to iterate on byte count, and actually, yeah, the byte number, I don't need to iterate on all byte count, yeah, because I know the byte number, and so let's write byte number, save byte number and save bit number. So this is the modulo, and same for the load. Bit number is modulo 8. All right, so actually I don't need to, I will need to iterate for loading, I guess, but not for writing. So the address, we will deal with it later. And so actually, I need to, because I just want to set one bit, but yeah, one bit of the current screen. Yep. All right, so it's 1 that we will shift by the save bit number, and I will, if I do that, I will delete the information of the previously saved. So actually I need first to read it, and then I need to update it and then save it again. So current byte value, okay, so it's get and then this one we will make OR, binary OR with this one. Actually, no, I need to set it, because if it was, well, that's a lot of bit operation. Never mind, we can fix it later. So let's think about the address now. So yeah, we can have a first, let's remove this. So the address has to be an int, because we can address 1 kilobyte in the EEPROM. So but this can be expression, I guess. So yeah, just forget about, yeah, static const int. So like in the Arduboy, they said the first 16 bit are reserved. So from 0 to 15, let's take the 16 one. So we start at this address, plus we want I, because we are iterating on all the people here. So I, but of course times 2, because we want to save an int which take 2 char. Then maybe I will store that into a variable int address, because I will reuse it later. Compute the beginning address for the current screen to save. For beginning address for the current item to save. Okay, save the item address. And then save the bit, the alive bit for the screen, for the puzzle screen. Save the alive bit for the puzzle screen to save. That's a bit complicated. I don't know if you're following what I'm writing, but anyway. So I get the value and then I will save it into the address, but the address will this plus the saved byte number. All right, so that's why I had this one. So basically, our address is okay, the beginning. Oh no, we need to add 2 also. So that's the beginning. Then we add 2. Okay, that's the int, and then we which byte we are saving, 0, 1, 2, 3, depending on how many screen we have. And then we are saving the current byte with the modification of the bit. Right, okay. But this one will only save at the beginning here. So basically now we need to do that depending on which screen ID we are saving. No, I'm saying something totally wrong. Yeah, no, we are iterating on the, what I want to say is we are iterating only on the dead people here. But actually the item that we will have into our dead pool will not be in the same order. So we should not just iterating this and give the address based on the I. Actually, in the data we want to, let me write you some what I expect to see in the memory. Okay, here. So what I expect to see is an address. So for example, so address, an item address. Then I expect to see the screen alive status for screen 0 to 1 to 8 to 7. Then a live status for 8 to, for screen ID 8 to 15, etc. So 16 to 23. and then we have this. Okay, so that's what I expect to have. If we have like 14 total living instance in the full game, that means here we should have 14 lines, right? Like this. This is our 14 instance. So basically I want to iterate in the memory on all these 14 lines, and then find the item address that is also inside my dead pool. So it's a double iteration. So since the loading is quite slow, so we should first iterate on this list, and then search if we find it into the dead item pool. All right, so let's let's change this variable to j. And let's iterating on I. So this one we will iterate on the number of max living item count per puzzle screen. And I guess this is our address. So this is really I. So now that we have the address, we should get it. But I need to get as a int. So I need to, that should return me an int, I hope. Maybe I need to specify get address. Yes, I need to the get function is taking f as a parameter. Address f. Okay, for example, float. All right, so that should be something like this. And item address. Okay, so this variable is a bit complicated. It's EPROM address, it's the read address, read and write address. So yeah, I'm thinking Now the update of writing the address is maybe not that necessary. We can just write it one time in the reset progress. No, even in something like init progress. But anyway, rename. I think I will rename this. Or we'll rename EEPROM address. That will be a bit more understandable. So I get the item address, then iterate on all the items to check if we found the current item. So if this as an int equal the item address, maybe I will write it the other way around. No, maybe I will write this way. So if we found it, then we should update the alive flag, and this is a bit useless. But when the EEPROM is empty, we at least need to write it one time. However, I don't know in advance unless I write a specific function from the map data to initialize that. So I don't know in advance the list of instance. So so I want to do I want to do a bit lazy programming. So or I don't know if it's lazy the word, but opportunistic maybe. So that means if I can find it, that's fine. If I cannot find it, then I should add it. Okay, so so here, if I cannot find it, that's fine. That means it's not this this item. We should move on. But let's say if our item address is zero, if zero. Yeah, that's okay. That I can do. So if the item address equals 0, we can initialize it later. That means that could be the first one, or that could be the fifth one. That means a new item that was never saved before. So let's save it. But I need to know if I found it or not. This algorithm is a bit complex. The dumping the state on the EEPROM is a bit complicated. So I'm trying to not write too much code also. say item found. What if I just write it like this? If item found yeah, I'm iterating into the dead pool. So if my item was not found, I can just save save the item. You replace the comment, sorry. Save the item address if we didn't no, it's totally wrong. We are iterating on the EEPROM here. Oh, I'm struggling with this algorithm. It's after I iterate all of them. If I didn't find some dead item, then I should add them. Yeah, then that means it would be maybe easier to iterate on the dead item array first. But that's a bit annoying to go through the EEPROM every time. Honestly, it would be easier if we can have if the EEPROM contains all the items already saved, all the address, so we are sure we can find it. Well. Yeah, if I can find it. If I cannot find it, it's maybe in the next line. It's not a big deal. Maybe I can save it, then remove it from the dead pool and try again. Wow. That's a bit complex to write. I generate quite a lot of code, but let's write all of them. I'm not sure if I can write a function that, opportunistically write the new item that it can find, and if they're already existing, it's just update it. That would be easier. That would be, not easier to write the function, but easier to use it. This function is called into the setup, I guess, if I will remember. here. And I don't want to have in the map data, if I have an array of all the living items, that's more data, yeah. But yeah, I don't know how to write this function. I mean, efficiently. Or I should read the item first in the EPROM, and then yeah, no, I think that I should delete them from here. Yeah, let's do that. All right, so move back to this here. So we iterate on the dead item. If I found it, I update my I update the bit, and then I delete it. Sorry about that. Ah, finally. I need remove with index. The item from the pool after updating. So we'll get back this function. It's basically these two. Yeah, okay. Okay, so let's declare it. And let's call it I'm not sure I will need this one with the pointer. Maybe I don't even need it. We'll see. Okay, so I iterate on all the prom. So the address, we start at 16 plus I times 2. So not this one, plus so it's I times 2 plus the number of byte count. Yeah, this one. So 2 for the address plus the number of byte for each screen. and we multiply this by I. Okay, so that's the beginning of each item address. Then we read this item address, and then we iterate on the dead item pool. If we find it, we update the bit, which is not correct now, but we'll see that later. That is not correct. Get, and I think it should be this one. Current byte, current byte value. So we get the current byte, we update it. So yeah, I need to increase so we need to move to the byte. Where is the byte that we want to save? So move to the address of the byte, saving the alive status of the current of the screen to save. Read and update the bit for the screen to save. So +2 for the address of the item plus the save byte number. We read it and then we update it, which again is not correct. Then we remove it, this one, and I guess we need to test again J, because we just remove it. So it was we switch it in swap the two value. So but actually no, we just break because we found it, so we don't need to search more. So we just break it. Okay. All right, and then after we check if there is some dead item remaining, and here also we can break if the address is new. If the item address is new, that means we reach the end of all saved item in EPROM. So we can just break. All right, so here check if there is remaining item to save. So if that item count is not new, or I can just iterate again, that's fine. So but the EEPROM address should not start here, so I will keep the variable outside of the loop. Yep. And actually, instead of the multiplication here, I can just add. I can start with that, and then I will just add at the end of the loop. For the next item to save. Okay, and then I will do the same here, compute it here in the loop. So this time we save the address, and then we save, we need to save the same kind of, okay, it was never saved before, so I can just update it. I don't need to read again. So I can just write it, and then, yeah. So that's the save. That should be the save function. And then we need to write. Actually, so I don't need a lot. Just to reduce the number of local variable, I can just rename this. So byte number, screen, well, I will call it screen byte number. Okay, screen byte number, and here I'll call it screen bit number. Okay, and here will be the same. Compute the screen byte and bit for the loads. All right, so loading should be easier. Loading should be easier. That's a pretty huge function, huh? So I don't know if will consume a lot of program. I'm not sure. I'm not sure if it's smaller than the first solution, which was saving the char in each item class, or creating a living item class. But we'll see. So we have to iterate again on the actually I want to iterate again, but maybe it's useless. Maybe I can also read at the same time. No, because I need to, I'm using the same temporary dead item, so I really need to clear it. So yeah, I have to unless I use local variable. Yeah, let's iterate again. We'll see. So we iterate again on the EPROM. We get the item address, and then, well, if it's 0, we can break. Otherwise, we need to read the alive status, the alive status of the current screen. So, but it has changed here, even if it's the same variable. So screen by number, we get it, and if this binary end with the screen bit, so yeah, by the way, I just save, like I said, it's wrong here. I always save 1, but it depends. Oh yeah, okay, so if it's data, save 1. Otherwise, if it's alive, it's not in the data pool, so it should be set 0. So yeah, it's still not correct. That's a complex saving, complex dumping. So if the bit is saved, is set, that means it's dead. So that means I should add the item to the dead pool. And which item? Well, the item which is here, item address. And of course, I cast it to item pointer. And normally here I should also remove it. I need to have a empty dead pool, so I can just reset it to 0. Reset the dead pool after saving all the items. Okay. If the item is dead for the next screen to load, then add it in the dead pool. And that should be it. That should be it. So yeah, that's, I'm saying it's easier to load it. And maybe in the dead pool we will have item that is that's probably not even on the screen, but it doesn't matter, we don't care, we have enough space anyway. Yeah, yeah, the saving seems a bit complicated, but all right. So here we are still not correct, I think, because yeah, I need to think about it more. All right. Okay, let's remove this. Then next we need to call that function, and yeah, we have declared it in the header file, I think. Yep. We need to call it, and I guess in the map manager when we do the screen change. So it's like begin. It's like okay, begin switch buzzer screen. We probably also need it to when we respawn to a checkpoint. Yeah. So, and before calling the, of course, before calling the init function, so let's call it here. Dump the progress in a prom. All right. Does it compile? Map data not declare. In progress, I guess. That is map data, not map manager. And I guess I forgot to declare it in the map manager. Oh no, map data is here. Huh? So in map manager, max item count per puzzle screen. Max item count per puzzle screen. External const and censure. Map data has not been declared. Yes, it has been declared. Map manager. Map data. Oh, it's all in map manager. Sorry. Yep, my mistake. Map data uses the same namespace. So let's remove it. And in progress. Ah, yes, it's not constant. I need a define. I mean, constant char. Can I declare I just don't want the map manager to generate another header file, but that would be nice actually. Well, let's change it for now. We'll handle it maybe later. Expected primary before dot. Yep, it's 2 dot. Sorry, it's not C#. Progression 7 was not declared in this scope. Progress. I think. Yep, forgot the scope of the function. Declaration of EEPROM address. I don't want to redeclare it. Okay, that compile, but I will not launch it. Suspense. Because I'm quite sure it doesn't work. It's full of bug, and but I wanted to compile to see the size. 75%. I forgot that we started at how much. I think it's pretty big actually. So I'm looking at the code now, and I find it wow. That's heavy. This function is quite heavy. Yeah? Not super satisfied about it. So anyway, I think I will not even commit this. We'll see that. I will work on it outside of the stream. Yeah, I think I need to first debug it, rewrite it maybe correctly, see if it works, and then I will test it. I'm sure it's full of bug, but basically that's the idea. That was the idea, my second idea, to save the progress. And yeah, maybe this strategy is even smaller than this one. So I really don't know. I'm not super happy with that, but yeah. Anyway, so yeah, outside of the stream, I will rethink about it, maybe re-implement it, and I will show you if I make some change, and probably testing it. And if it's fine, then we can switch again to the editor. We can switch to the editor because and then the editor will be much easier to write, actually, to export, and also the load, because yeah, as you can see now, the editor is basically just a series of init and also the checkpoint for some screen. So the editor will be much easier to write and to read also, because I just have to read this init to know all the item that I need to spawn into the editor. That will be easier. But to make sure that this is okay, we can go with that design pattern. I still want to be sure that our progress, the way we save the progress, is reasonable and it's working, is okay. So yeah, I will do that. I will keep you informed in the next video. As usual, thank you for watching. As usual, if you have questions, don't hesitate to ask them, write them in the comment under the video, and I will try to answer them in the next video. So anyway, thank you for watching and see you in the next video. Bye bye.